He's one of the most important guys in Photona organization, and he's a brilliant and clever one. Okay, thank you. He's going to talk about.
Thank you.
New Láser Photona Starwalker. This is the Starwalker MaQX.
Yeah. Hello, everyone. It's a pleasure to be here again after 1 year, and I see quite some familiar faces from last year. I think so far it was an excellent meeting. So today I will be talking about this device. It's a new laser. It's our latest product, which we launched in January. And I know that already in Spain there are a few installations already. And I have a question for you. How many of you are using Q-switch lasers? Not many, but okay, I hope it will be interesting anyhow. So this is the laser which we call Starwalker. In Photona we start to use the names which are connected with the Star Wars, like Lightwalker and now Starwalker. We invest quite a long time in development of this laser, more than 4 years. Some of you would know our previous Q-switch laser, which is called QX Max. It's an excellent device, but it was lacking some features like a touch screen, like detection of the spots, and so on. So we decided to develop a new one. And when we start with development, this was before then Pico systems came out. So our design for the project was to produce a nanosecond laser. But as the picosecond lasers appeared, we changed our course of development and we included some pico features in this laser. So first feature, I will go through several features which make this laser unique. The first feature is so-called hybrid pulse. I call it hybrid pulse because he has a train of picopulses in duration of 5 nanoseconds. So it's not a single pulse, it's a train, you can see here. And the central 5 pulses are quite strong. And we can get, let's say, best of the both worlds of enough power, like we have in nanolasers, and interaction with the tissue, as people have with pico lasers. We were able to do this with a special design of our heart of the laser, which is a resonator, laser resonator. You cannot see this on this picture, but here inside the resonator we have additional element, and with this element we are producing this hybrid pulse. We apply for patent because it is something totally new, and we hope we will get this patent soon. We call this TMD technology, which means transverse mode discrimination. So we can discriminate the laser modes and take out this kind of hybrid mode. If we compare this with the other pico lasers on the market, if we look into these pictures of the pulses here, the first laser on the market was like this. So it was 200 millijoules in one pulse, it was 750 pico, and the peak power was 267 megawatts. So our central pulse in this train is 300 millijoules, 580 picoseconds, and 500 megawatts, so much stronger than that one. And then if we take into account all of 5, because all of them are contributing to the interaction, we have more than 1,000 millijoules. So this is the strongest pico train on the market. And if we take into account the whole pulse, we have 1,600 millijoules. And this is again giving you the power. And why you need power? You need power to be able to work with larger spot sizes. If you don't have enough power, like with this one, your fluencies on normal spots like 4, 5, 6, 7, 8 are very low. You cannot do practically nothing with this. Just to illustrate this, this is a graph which is showing the spot sizes versus fluencies. And these are some nano lasers on the market. This one here was our QX Max, and now our Starwalker is even higher. And this is the first pico laser. So the first pico laser with 200 millijoules, when it comes to the spots of like 4, it's below 1 joule. So what you can do with 1 joule, maybe just some light toning. this is one of the reasons why you have to have a big spot to have enough fluence for decent treatment. And secondly, with the larger spots, you treat the region quicker. So instead of spending many shots, you can spend a less number of shots and treating the area much quicker. This is one comparison we did between QX Max and the first Pico laser, just to show that there is no big differences in fact when we are treating tattoos. Although when Pico lasers came out, everyone was promoting this as something really beautiful and excellent for tattoo removal. But after the first session, you can see that actually QX Max was more efficient, and also the settings were the same. The second feature of this laser is again something totally new. We are introducing a new power supply. So this is the third generation of power supply. We call this adaptive structure pulses. I will not bother you much with technology, but all of you probably know about square pulses, variable square pulses, which we have in dynamics, in spectros, in all of our lasers. This is a big advance in comparison to the non-process pulse. And now we have a new possibility. We can shape the pulses however we want. So we can produce, let's say, ramp. We can produce a kind of step, and depending on application. If application requires a particular power delivery, we can do this. And not only this power supply is much more efficient than the old ones. It's smaller, it's more compact. If you look into this system, it's quite small. And I will show you a picture in comparison to the other Pico systems. You will see the difference in size. And this reduction of the size we achieved with the new power supply. And not only reduction in the size, but this power supply can generate many strong pulses in very short time. So this is giving us a new feature. And this new feature we called MaQX, modulated acoustic Q-switch pulsing. And if we are looking in standard single pulse and standard dual pulse, which is called PTP, this is what we can achieve with the Starwalker. So this is like our PTP, much stronger, with 2 pulses, with 5 pulses, with 10 pulses, we can come to 10 joules. So no one on the market can exceed 2 joules in this moment. And this gives us some maximal features, like 10 joules, 20 millimeter spot, 15 hertz. So such kind of laser doesn't exist in a Q-switch world, doesn't exist on the market. One of the features which we brought from the old system is this vacuum cell technology, which we use to make a perfect beam profile. I will not bother you much with this. If someone is interested, I can explain later, but this is unique feature which we patented and which is giving you much better profile than this profile shown here. Or for example, this kind of profiles which were like a golden standard in past. This was a Medlight C3, Medlight C6, Revlight. You can see all of these non-uniformities in the beam which are caused with the beam transfer. And if we are using this kind of beam transfer to go focusing, defocusing, we get an excellent profile. And why no one else is doing this? The problem is in these focuses here. We have here extremely high energy, concentrated in very small spot. And in normal articulated arm, there is air in it. So when the air came into interaction with such strong energy, we get explosion. We get a micro explosion, and we lose all the energy. If we want to pass these focuses without loss of energy, we have to put it into the vacuum. And this was our solution, which we patented. So we have vacuum tubes with the reason to bring the beam out, which is non-disturbed, and it looks very nice as a profile. And the good profile is giving you a smooth operation on the skin. You don't have a hot spot, you don't have a pinpoint bleeding, and some untreated areas. Also, the articulated arm is very specific. It doesn't have a weight. You know, in dynamics we have a counterweight, which is a good solution, but this one is better. So this is again one of our specific features. And if we are looking what we have built in, we have two wavelengths, two basic wavelengths built in. One is Nd:YAG and the other is KTP. And in Nd:YAG, I explained this hybrid pulse. So we have a hybrid pulse in a Q-switch mode. And then we have FRAC3 and Versa. It's a long and short. But these two pulses are giving you photothermal interaction. Q-switch is photoacoustic, and these are photothermal. So they open the whole area of applications which you would usually do with Dynamis, for example, or with the long pulse Nd:YAG. But here you have inside the Q-switch system, you have a long pulse Nd:YAG. And not only long pulse Nd:YAG, but also long pulse KTP. And this is also a revolutionary thing. There is no such Q-switch lasers on the market which have a long pulse KTP. So with the long pulse Nd:YAG and long pulse KTP, you get a vascular laser. This is actually a laser which can treat all vascularities, from superficial red to the deeper blue with Nd:YAG. We have two additional colors as we had before. This is 650 and 585. This is for different colors of the tattoos. And if you look into the whole modality, this is what this laser can deliver. So it can deliver 3 modalities of Nd:YAG, 2 modalities of green, and then 1 modality yellow and red. And these 2 wavelengths does not have a hybrid pulse. So conversion from green to red and to yellow is losing the structure of picopulses. Range of application is quite larger than ordinary Q-switch laser. Q-switch lasers usually do pigments and tattoos, and that's it. Here you can do many other things. This is what we have already in other systems, like in Dynamis. This is internal self-calibration. This is an excellent feature. You don't see it, you don't sense it, but without it, you will have a problem with calibration. So laser is self-calibrating itself by every pulse. And this is what I was talking about, the sizes. So these are 3 pico lasers, and on the Congress in San Diego, we have neighboring booth, so we bring the laser to neighboring booth just to show the difference. So it is relatively small, it's light, and you can connect it to ordinary power supply. You don't need some specific electrical connection. You just use ordinary plug, 16 amps, fuse, and it works. This table is just to show you the specification if someone is interested about the maximal fluencies, maximal frequencies, and so on. And a list of these features which I just mentioned. And I would add here the 11th one, which is silent operation. When this laser is operating, you practically don't hear it. Many other lasers need a lot of cooling power to cool down the power supply. But here, power supply doesn't need such cooling. We have quite some handpieces for this laser, more than before. And all of these handpieces are detectable. So we connect here the cable. You can see here the cable. We connect it to the handpiece, and then a laser recognizes the handpiece and recognizes the spot. Standard handpiece is dual wavelength, Nd:YAG KTP, zoom 1. You can go from 2 to 8 millimeter, and this is used for many, many applications. Also, the novelty is this quick connect. Just plug in. You don't have to screw it in and unscrew it out. It's the quick connect. And when you connect the cable to the handpiece, the laser recognizes it, and also it doesn't let you change the spot size on the laser. You can change the spot size only on the handpiece, and laser will follow. We have a specific handpiece for the long pulse KTP. We call this modality Verde. It's also color marked, that you quickly recognize the handpiece, and we use it for the vascularities on the superficial red vascularities as any other long pulse KTP. We have a new handpiece which is used for low fluencies, and it is used in Nd:YAG for large spots, 10, 12.5, and 20, and for KTP for small spots, low fluence. Sometimes we have a need to treat like small freckles on the face with very small spots and low fluence. It was not available before. And we have a range of fractional handpieces, and this is a new chapter. Q-switch fractional handpieces. It is quite a big novelty. We have it already a few years, but in this system, first time they are fully integrated into the software. So here you have a matrix, how the handpiece looks like. You have expression of the intensity in millijoule per pixel, which is the correct one. And we can work in 2 modes. One is a non-ablative and the other is ablative. So with ablative mode, we can drill the holes in the skin. We can do a skin resurfacing with the Q-switch laser like we are doing with erbium, for example. Fractional ablative. This is an example of non-ablative, although we have some pinpoint bleeding because this guy was using a little bit stronger parameters, but the idea is non-ablative. non-ablative treatment of such kind of redness. You get erythema, but it is short lasting. It's, let's say, maximally half-hour lasting. It's painless, and it's quick. And you can get very nice results on diffuse redness. Diffuse redness is not easy to treat because the vessels are so small, you cannot go after them with 2 mm spot because you don't see the vessels. But with this kind of coverage with the fractional Q switch, you can actually break a lot of these vessels. There is no strong pressure behind to fill them back. And then you can get such nice lightening of the redness. There are several such examples. This is a new feature, in fact. We didn't have such nice modality before for redness, diffuse redness. Also for active acne, you can treat active acne in the same way with the fractional Q-switch non-ablative mode. Again, you have kind of erythema, redness on the face. This is immediately after. And then you can see some cases of such kind of treatment of acne just with the neodymium Q-switch fractional non-ablative. Of course, rejuvenation is one of the applications, so very gentle rejuvenation of the skin. Again, you get just erythema, which lasts for short time. Here, for example, there was no pinpoint bleeding, so he was using normal settings. And this is a result after one session. It's a mild improvement, but patients love it because of minimal invasiveness. Some other cases when you can see kind of improvement, if you look into this area, it's a nice gentle improvement, single treatment with the fractional Q-switch NDAG. And of course, pigmentations you can treat with a full spot, with the toning, with the KTP and also NDAG. But you can also use fractional NDAG Q-switch. And you can get a minimal invasive treatment, like in this case of melasma, quite nice clearance after 2 sessions. This guy tried also to do stretch marks. This is just a single case. He's showing the redness immediately after and showing some improvement, but it's too soon to talk about it. We have also a fractional hand fist for KTP. So KTP is much more aggressive wavelength. And it will give you a longer downtime. So if you fractionate it, you can improve the downtime and keep the effect. This is décolleté treated with a fractional KTP Q-switch. Another one. And you can see how it looks like the downtime immediately after. So it is not so innocent, but again, it is not too difficult. It clears up in like 5 days. The second big segment are tattoos. One of the reasons for this pico development and everything is because of tattoos, to decrease the number of sessions. We have here, aside of KTP and NDAG, we have these additional 2 colors for multicolor tattoos. And this is the technology we developed in the last 4 or 5 years. We call it FracTat. And it consists of 2 steps. In the first step, we do the pre-drilling of the tattoo, and in the second step, we shoot with the full spot. Why we do this? The idea was to increase the efficacy, reduce the number of visits, and shorten the time of treatment. So although the Q-switch lasers are golden standard for the removal of tattoo, this technology is connected with these 2 problems. So it's too many sessions and too long time. So everyone is aware of this, and everyone is looking how to shorten this. And development went into 2 directions. Firstly, I will demonstrate you what does it mean. So this kind of tattoo, if you treat with all of these colors, this is a single pass treatment on the first visit. You see this frosting effect. This frosting effect does not allow you to go second pass because you cannot reach the pigment. This is the moment when you send the patient home. And in this way, you treat it and treat it. This is after 4 sessions and 6 months' time. And this is the final results after 10 sessions and almost 2 years' time. It's excellent result, but it took a lot of sessions. It took a lot of time. If we look how this reduction of pigment is going, it is going slower and slower. So it will be excellent if we can, let's say, make it in 5 sessions, for example. So one idea which was proposed in 2012 by Rox Anderson Group was to do repetition every 20 minutes of the new pass And with this waiting of 20 minutes, what you achieve the clearance of the frosting effect. So frosting effect is caused by gases which developed in your extracellular matrix. When you break the pigment, you break also the cells, and there is gases developing. Mostly it's nitrogen, and it gives you this whitish appearance, and it will evaporate through the skin, but it takes like 20 minutes. So the idea was, let's wait 20 minutes, and then we can go second pass, and again wait 20 minutes and do the third pass, and so on. So this is an article which is discussing this technology and showing some good results. We tried this, but we find out it's not easy to do this. It's problematic, but it gave us an idea. It gave us an idea to make the holes in the skin, which will enable the gases to penetrate the skin very quickly, and then you can do the second pass, not after 20 minutes, but maybe after a few minutes. So we started with the dynamics. We started with the fractional erbium YAG, and then with the Q switch. Of course, then you need 2 lasers. And our results were really good. This is the first study done by Dr. Marini. We did a split tattoo study. We pre-drilled this part, and we left this part untouched. And then after first pass, you can see the difference. This is a frosting, normal, and this is after pre-drilling. There is some pinpoint bleeding, which is not problematic. You wipe it off, and you can go second pass. So this is the difference in effect. You can see this is multiple passes in a session. This is a single pass in a session. So it's obvious improvement. And we achieve even to remove some light tattoos in single treatment on this kind of technology. And then, of course, why should we drill with another laser if we can drill with the same laser? This was the idea. So introducing fractional Q-switch handpiece for drilling the skin. And we patented this. This is our patent. It is showing the drilling and then shooting the tattoo. And with the Starwalker, we are using this kind of 5x5 matrix to drill with strong parameters, and then this kind of parameters to remove the beam. And we measure actually the depth of this drilling. We did some histology, and for example, we can achieve like a 0.5 millimeter deep drilling. And here, as Q-switch is totally cold, it has predominantly photomechanical effect. You don't have coagulation, so you have much more bleeding than with erbium. This is blood. So blood is coming out, but we find out it's beneficial. It's nothing wrong with blood, it's even beneficial. And when you pre-drill the tattoo with Q-switch, it looks like this. So this is a case on the neck. Usually such kind of tattoo would take like up to 5 sessions, 6 maybe 7, it depends on laser. And in this case, it took 4 sessions. And you can see the skin is really beautiful. So it also get a fractional ablative resurfacing, aside of removal of tattoo. This is another example when you can see the result after 4 sessions only. Such kind of tattoo will take at least 7, 8 sessions. And this is a big tattoo on the chest. You can see this kind of blood is seen immediately after first pass. But the clearance rate is really great. This is the final result, and this is after 5 sessions. So we actually achieved reduction of number of sessions, improved the efficacy of the treatment with this technology. This is just another example, 5 sessions. And one more thing, we achieved these effects of resurfacing of the skin. This guy came after 14 sessions, so he was treating with some strange things like IPLs and so on. And the tattoo is still there, but he got a scar. You can see the scar. So he was treated in this way like 5 times with the fractat. And the final result is not only total removal of tattoo, but also improvement of the scar. So here the scar was improved by a fractional resurfacing of the skin with the Q-switch. And in average, we are not having any more 10 sessions. In 2 years now, in average, we have like 3 to 5 sessions in a half time. So this is a good improvement of the removal of the tattoo. There is an article written about this. I have it. If someone is interested, I can give it to you. Of course, if we can do this on tattoos, why shouldn't we do this on pigments? We can do the same thing on pigments. And this is one of the first cases of Dr. Marini for this Nuevo. He was treating it with the erbium YAG pre-drilling and shooting the Q-switch on it. And you can see here, not only again that the pigment is totally gone, but look at this skin. It's beautiful skin, much better texture than here. So resurfacing a side of removal of pigment. When he moved to the Q-switch fractional and the Q-switch full beam, so without erbium, in this example of Nuevo Sofota, this was achieved only in 2 sessions. So the people who treat Nuevo Sofota, they know that for that, such kind of lesion, you need at least 4 to 6 sessions. So excellent results. And last but not least, sometimes people treat hands as well. Hands are very grateful area to be treated. You can achieve excellent results. And here again, we use this combined method. And you can see some very nice results treated with the Q-switch laser. Also, of course, classical pigments like lentigo senilis and such stuff as well. So no wonder that in this half year, as long as this laser is on the market, it already got an award on the World Congress in Las Vegas as the best new technology. And just last month, we got also the FDA clearance for it, so it's now in a full speed, also present in the United States. So thank you very much.